I am Eric Christensen from the University of Rochester in the Institute of Optics, and today I'm going to do a little demonstration on solar cells, particularly photovoltaic solar cells and silicon especially. Here's my little demo here. I have a flat plate silicon solar cell, and I have it hooked up to a motor here that I'm going to show how a solar cell works. Here's my fake sun, just a basic 75 watt bulb, incandescent light bulb. And as you see right now, we have the light is hitting the solar cell, and that's generating a current that is then going through the wires into the motor and causing it to spin. If we start to cover it up, it's still working, but then once we cover up enough of it, it's not getting enough photons from the light to generate the current it needs to spin the motor. But if we uncover it again, we can see that it works. And so that's the idea behind a flat plate silicon solar cell. It can take the light and convert it into electricity, and in this case, spin the motor. However, another concept with photovoltaics is concentrating photovoltaics. Many solar cells are very expensive, more expensive than silicon, so you don't want to have a whole flat plate of the material. And so you'd like to cut down on the amount of material you use in order to lower the cost. So now if I take this aperture to cover the cell, so now I now have effectively a smaller chip. But you can see that the motor is not spinning, so there's not enough light hitting the chip to make the motor spin. But what you could do is, instead of just having this much light hit the chip, if you take a Fresnel lens, you can put it over top and focus the light down so that now you get the whole area of the Fresnel lens now collecting light. Because you can get all that light now shining down onto the solar cell. And so now this chip that before didn't have enough light to generate the current to spin the motor, it now does while we put the lens over top. And this is the idea behind concentrating photovoltaics, is to use some type of optic to generate, collect more light for a smaller cell. And in that way you can effectively reduce the size of your chip, which will reduce the cost. And for many photovoltaic devices, especially with those that are higher efficiency, being able to use less material for a given area is very important to save you in cost. And so, again, we can see that we can collect a lot more light for a given size chip and still generate enough power to power the motor.